Hello, my name is Selena Noltenius, and this is Lab 23, Kirchhoff's Laws, Experiment number 2, Resistors in Series and Parallel. And this is for Physics 2 Laboratory. So, as an intro to this lab, as I said in my last experiment, for all three of these experiments, we used um, three setups that centered on Kirchhoff's laws to study the behavior of electrical circuits. In the second experiment, resistance, current, and voltage were quantitatively measured in comparable configurations. So here we have a picture of myself with the materials and the kit, and here you have a closer picture of the Snap Circuits kit, the digital multimeter, and the two AA batteries, and the two in the AA battery holder. So right now, this is what my experimental setup looks like for part 1, series circuits. So I'm using figure 15 here and mimicking this on my board. So I have my 1K resistor and my 1000 resistor over here. And now I have my multimeter set to the 2000 mark over here. And now I'm going to measure the exact resistance of the 1K resistor by touching the red and black probes to opposite ends of the individual resistors. So, using my multimeter, we're gonna measure, and here you'll see how so it's 900 and I don't know if you see it, but it's 992. 992. And now I'm gonna do the same. That's 992 for the 1000 resistor, 1K resistor, and then for the 100 resistor, it's gonna be about 199. Okay, nice. Now I place this 2 snap conductor in between the 1K and the 100 resistors. Now I'm gonna measure. I'm gonna measure the total resistance across both resistors by touching the red probe to the left terminal of the 1K resistor and the black probe to the right terminal of the 100 resistor. So, as you can see here in the multimeter, seeing 1081, 1080. This video. Now I place this 2 snap conductor in between the 1K and the 100 resistors. Now I'm gonna measure. I'm gonna measure the total resistance across both resistors by touching the red probe resistor and the black probe to the right terminal. 81, 1080. Now I have set up my circuit so that it looks like figure 17, as you can see here. And now I have my multimeter turned to the DCV section to the 20 mark. And now I'm gonna measure the voltage drop across the 1K resistor. So we're going to place the red probe here, and we're going to touch the black here. We're going to see how it's 2.92. And then we're going to do the same for the 100 resistor. So it's going to be here. Since I'm getting a negative reading, then I have to switch sides. It's going to be 0.29 for the 100. Now I have set up. Now I have removed the 2 snap conductor, and now I'm placing the red probe touching the battery, and then the black probe touching the resistor to see and measure the current going on through the 100 resistor. So it's the current, let me see. Again, one more time. 2.92. Now I have and now we're measuring the current going through the 1000K or the 1K resistor by connecting the multimeter in series with it. We do this by removing the 3 snap connector, so this one which was located here, and then by touching the red probe to the 100 resistor, and then the black probe to the 1K resistor. We can see it's 2.92. And now we're measuring the. This is part 2. Now this is part 2, parallel circuits. I now have my multimeter set to the 2000 mark in this section of the multimeter. And now I'm going to measure the voltage by placing, or I'm going to measure the number in the multimeter at this mark. Then I'm going to place the red to the right for the 100 resistor. The resistance here is going to be I see 100. So 100 for the 100, and then we're gonna measure it for the 1000. $992. Now this is part 2, parallels. Now we have connected both resistors, and we're gonna measure the total resistance across both resistors by touching the red probe to a terminal on the left conductor, like this. Now we have connected both resistors, and we're gonna resistors by touching the red probe to a terminal on the left conductor, like this, and then the black probe to a terminal on the right snap conductor. So we see that it's 91. Now we are measuring the current through the 100. Now we are measuring the current through the 100 resistor by connecting the multimeter in series. So we removed the 2 snap conductor that was currently here, and now we're placing the red probe and touching it with the 3 snap conductor, and then the black probe to the 100 resistor. And it's giving me a 3.15 reading. And for our results, table 1 shows the resistance, voltage, and current data for series and parallel circuits configurations, where we see the different circuits variables as the first column, and then the second column being the resistors in series, which is part 1, and then part 2, which were the resistors in parallel. And one of our main questions for the post lab was um, asking how we should draw a conclusion about the current voltage of resistors in series and about current and voltage of resistors in parallel. So for series circuits, we noticed how the current through each resistor was the same and how the voltage is divided among the resistors, most specifically R1 and R2 in our case. And then for parallel circuit, the voltage across each resistor was the same, and the total current is the sum of the currents through each resistor. Thank you.